All right, good morning, e-learners. Jackson, why did you refuse to be an e-learner when you were sick? We all missed you.
You were totally
like I woke
yeah,
up.
yeah,
like
yeah,
on
yeah,
Monday, I woke up like 2 minutes before the Zoom call, and I came downstairs in like a t-shirt and my underwear. I was like, no.
Well, thank you for not showing up on Zoom then.
I would have. Yeah. I just like calling my.
That's Algebra 1.
I should have been a new learner.
All right, sorry for floundering around here, e-learners. Trying to find which one to share with you. I need to share 2.3, this one. There we go. Now I got to figure it out. All right, that took way too long. Who's absent today? Callie and Abby? All right.
Everyone's absent.
All right, any questions before we grade? Questions before we grade?
I didn't understand.
Has all the note passing been done? We got that over system? Okay.
That was you, Landon. That was you. Yes, it was. I'm just sitting here. I'm the one.
Until I start, that's what floats your boat, whatever, but while I'm teaching you something. All right. No questions, really? It was that easy?
Well, I don't know.
It's so hard.
Yes. All right. Hey, time out so I can hear the question. Guys. What's up, gentlemen?
How much is my grade will be missing because I missed, like, I forgot to do one question.
You're fine. You're fine. All right, rounding. I started the class by saying this is a straight up review, and that Christian should have been able to teach it, but he got chicken or something, and he wouldn't do it. Christian, was this a hard or an easy assignment? It was easy. All right, so here we go. I'll answer in a second. Number 2 is 80. Number 4 is 70. Number 6 is 110. Number 8 is 100. Number 10 is 26.8. You're like, wait, shouldn't it be 26.80? Well, that's right, but we just don't put zeros for decimals. Number 12 is 12.4. Now, if you put 12.40, that's fine. 12 and 4/10. Number 14 is 8 and 1400ths, or 8.14. Number 16 is 0.71, or 7100ths. Number 18 is 12.357, or 12 and 357 thousandths. Number 20 is 30.032, or 30 and 32 thousandths. 22 is 7.006, or 7 and 6 thousandths. Number 24 is 1. That was kind of anticlimactic. Number 26 is not A. It is
C.
It is C. Number 28 is A. And 30 is
A.
C. And the last one, 32, is B. Yes.
So, I am forgot to expand it for my writing. Writing that. Oh, that's
All right. Make sure your names are on them. A few of you are still forgetting to put your names on an assignment. Make sure your names are on them. Okay. Check the board. Write down the homework for tonight's. Check the board. Write the homework for tonight's. Nothing going on till next week. It's frozen. Au contraire, it is not frozen. All right. Hey, Time out for a second. Let's do this quietly, please. Yes, Jace.
Is it okay if I wrote with the number and said H to B?
Fine. Of course, now you don't know if you got it right because I didn't call out the number, right?
Oh no, I had to look in the book.
Okay, good for you. Yeah, that's 2 years.
Oh, and these. Yeah.
Thank you.
I'm gonna try and get all three assignments done in class.
Okay, the part where I asked you guys to do this quietly, you are failing at that miserably. Thank you. It's not that you can't talk, but let's just, the loudness just gets in the way. Make sure your homework gets to Grayson. All right. Some of you are looking at the sheet in front of you. You're like, I have no idea what this means. There's 3 letters there. Others of you are like, oh, I remember doing this from last year. We will see. We will see. We ready? All right. Clearly, there's not a lot of homework here, so that means it's either word problems or something complicated. All right. Let's see if it is complicated. From pre-algebra all the way on through high school and even into college, if you take some math courses, one of the first classes you get are something called basic properties. You will be getting today's class in nearly every single math class that you take from now on. It's kind of like when you do learn addition. And then for the next 6 years, you get classes on addition. Well, you're going to get the same thing on what are called basic properties. Basic properties allow us to solve equations. And what allow us to do basic math. Like, well, how did I get through to 8th grade without having this class and doing math? Good question. All right, wow, look at all those objectives. So we will talk about them, and they're complicated. We'll talk about them when we get there. Write this down, please. Box 1. A property in math is defined as a mathematical statement taken to be true. A property math, and I'm not talking about 2 + 2 = 4. I'm talking about a general property. Write this down. Landons, plural. A mathematical statement taken to be true. Here's a property. If you add 0 to anything, what happens? Nothing happens. There's a property of math. We actually give that a name. Anybody know the name of it? It's called the zero property of addition. You add 0 to anything, nothing changes. We will write that down, just not right now. That's not one of the properties for today. But that is a property. It says taken to be true. Did I need to prove to you that if you add 0 to anything, nothing changes? No, I don't need to prove that to you. Okay. All right, so properties are mathematical statements taken to be true. In math world, we call these the rules of the game, right? They're how you do math. And I'm not talking about how you do addition, subtraction. I'm talking about some of the finer details of addition, multiplication. We accept them to be true because they're basic statements. Add 0 to anything, nothing changes. We okay? You did not need to write this part, just the part in blue. Aristotle, famous mathematician and philosopher, he called these the common things. There's some background historical things. Hey, here's a common thing your mom or your dad tells you. You don't clean your room, right? Your mom gets upset, right?
My mom doesn't care.
Do I need to prove that to you? No, we take that to be truth. It's common, right? You better have your room clean, right? If your mom lets you have a messy room, congratulations, right? Most moms, that's not the case. All right, so now what we're going to do is I'm going to give you properties. Some of these you may have been exposed to, others of them you have not been exposed to. The first one, here's the setup. Hey, what's 5 + 6? Thank you for participating. What's 6 + 5? Well, how in the world, why do we get the same answer? Okay. Will that be true for all numbers? Who said no? Give me an example where that's not true. Oh, it's true for addition, he's saying. So is it true just for addition? Okay. Yes, Gabby. We're only talking about addition here. So is it true for all addition? That the order doesn't matter how you add them, you always get to the same number. Is that true? Do I need to prove that to you? That's why it's called a property. I don't have to prove that to you. That's kind of common knowledge. 5 plus 6 is the same as 6 plus 5. We're going to give this one a name. Anybody know it? That doesn't have the book open and looking ahead. All right, let's write this down. First property. Now, they're not going to say 5 plus 6 equals 6 plus 5, because this is going to apply to all numbers. So they say instead that A plus B is the same as B plus A. Yes. We are about to write this in box 1. All right. So it says A plus B, and then it switches the order around, and they write B plus A, right? So we've moved the numbers. Now, granted, they're variables here, but we've moved the values around, and we still get to an equality. If you move the numbers around and you get to the same number as an answer, we have a name for that. We call it, we've commuted, we've moved. Therefore, this property is going to be called the commutative property of, and that's what you're going to write in box 1. If you think about commute, hey, these are commuter trains. People get on and they move. People commute to work. They get in a car and they move. So if the order moves, changes, right? I'm now no longer at home, I'm at work. If your position changed, you do what's called commuting. So yes, box, why did I say box 2? Oh, that's right, because property was box 1. Sorry. He's got it flipped over, and I keep looking at his. So it's got to be Landon's fault, not my own. Right. No, it's my fault. Write this down, please. This is called the commutative property of addition. A big mouthful of words there. Commutative property of addition, which states exactly what we just said. That if you add any two things and in one specific order, you can move that order around and get exactly the same number. This is box 2, yes. A plus B is the same as B plus A. Now, Grayson said, and Gabby, well, it's true for addition, but it's not true for other things. And that's true. That's why it's not called the commutative property. It's called the commutative property of addition. It's definitely not true for subtraction. Different number for subtraction. Not for addition. For addition, if I take A and add it to B, well, it's the same as taking B and adding it to A. You don't need to write these arrow things. I'm just showing you that I've moved the order around. I still get to the same thing. And it's important that you remember this is for addition. That's a long thing to write. Guess what you're going to have to do tonight for homework? They're going to say, name the property. Guess how many times you're going to write this? So many times that you're not going to want to write it. So guess what you're going to write instead?
CPA.
You're going to write CPA. So Merry Christmas. We okay? All right. So what's missing obviously is subtraction. 5 minus 2 is? 5 minus 2 is?
3.
Is that the same as 2 minus 5? We do not have a commutative property of subtraction. You move those numbers around, you get different answers. Right? There is no commutative property of subtraction. Only addition and one other. Okay. The consequences of the commutative property of addition, or CPA, are this. Right? You are allowed, if you listen carefully what I say, if all you have is addition, no subtraction, no multiplication, no division. If all you have is addition, you can move those suckers around any way you want. Right? If all you're doing is adding, you can add them in any order that you want. That's the consequence of CPA. Well, is that a good consequence? Sometimes it will be. Tonight for homework, it will be. They're going to give you numbers that you can move around and make your life a little easier. So it allows you to move the numbers around when only addition is involved. So what? Right? You've probably already done this before. Like you've probably already noticed this before. You just didn't realize you can do this. All right, here's an example of CPA. See the numbers? If I ask you to add them by PEMDAS, we would have to do what? By PEMDAS, we would have to do what? Left to right. However, right, is there any subtraction, multiplication, or division involved? If that's the case, you may use CPA and do it in any order you want. What would be a smarter order to add them in?
25 plus 5 plus 110.
Yeah, it would be smarter to do 25 plus 5 because that's 30. And 30 and 110 is, you have commuted the problem. You've moved the numbers around to your benefit. But you need to remember, CPA is only for addition. If there's any subtraction, multiplication, or division involved, you cannot do this. But if there's only addition, heck yeah, make your life easier. This is the first time I literally said something. I got my mask on, now I'm out of breath. I thought this was going to happen all the time, but I don't know why that particular one. I was like, wow, I'm out of breath. I just was probably saying too much. All right. If subtraction, division, or multiplication involved, you must not move anything. You must use PEMDAS. PEMDAS, right? So, hey, we got any subtraction, multiplication, or division involved?
Addition.
Do we have any subtraction, multiplication, or division involved? No, so we can move this around. So, Brecton, move these numbers around. Make your life easy. Yeah, I do 25 plus 5, and then how about look at the other grouping you could do? Wouldn't it be easier to do 2 plus 8 first? That gives you, yeah, and then added that to, isn't that easier? So will this always be this easy? No. But tonight for homework, they're going to give you numbers that they expect you to move around because they are, I don't know, easier numbers to mess with. You know, if this wasn't a 2 and it was a 3, this wasn't a 25, it was a 29, then there's no friendly numbers. Then you have to go left to right. But for this one, you can commute. How about for this one? Can you commute this one? Why not? Because there's subtraction involved. You have to go left to right. So this one, no way. You got to use PEMDAS for that one. Go straight left to right. Left to right. All right. So box 3, here we go. Let's see. The first 3. Are there any friendly numbers here? Oh, yeah, 6 and 14. 6 plus 14 is plus, what do we get? You did that in your head. You didn't even have to do a calculation on paper. 6 plus 14 is 20. 20 plus 420 is 440. Okay, you were using CPA in order to get to the answer there. Brecton already did this one for us. 2 plus 8 is 10. 45 and 5 are 50. 10 and 50 gives us 60. Makes your life easy. But I'll just say, this only happens infrequently in real life. Tonight for homework, they're going to give you numbers that you can, oh, look, it's 30 and 20. That's 50. Right? So it doesn't happen often in real life. Well, we're going to look at that one here in a second. All right, we good with CPA? All right, next property. What's 3 times 2?
6.
What's 2 times 3?
6.
So what's this property?
CPM.
Commutative property of, and just like addition, you can only use this one when only thing you have is multiplication. Okay, so write this down, box 4. CPM, commutative property of multiplication. It's our second property. Commutative property for multiplication looks exactly like the one for addition. You just replace the addition symbols with multiplication symbols. A times B is the same as B times A. A times B is the same as B times A. Good? All right. Notice the order is changing. We still get to the same answer. We're moving. We're commuting. What's missing? What's 10 divided by 2?
5.
What's 2 divided by 5?
1.
I'm sorry, 2 divided by 10. Sorry. Well, that's not 5, right? So, do we have the commutative property of division? Heck no. So, There is no commutative property of division. 2 divided by 10 is 0.2, right? Yes? You're thinking of 1/5, which is 0.2. All right, what are the consequences? Same thing as CPA. If all you have is multiplication, you can multiply in any order that you wish. So if you just have multiplication, pick and choose. Tonight, they're going to give you numbers that are friendly to multiply together. So what would that look like? Let's take a look at an example. Here's an example of commutative property of multiplication. See the numbers? Without CPM, we would have to do what? Without CPM, we would have to do what? Go, say it. Follow order of operations, left to right. 2 times 12 is 24. 24 times 5 is, okay, I can't do that in my head. I got to do scratch work. Oh, check this out. All I have is multiplication. What are the 2 easiest ones to multiply? What is 5 times 2? Times 12. See, we'll make your life easy on occasion. Okay? 2 times 5 is 10. 10 times 12. You're doing that math using commutative property multiplication in your head to make your life a little bit easier. Yes, Brecton? Yeah. All right. Remember, if there's any subtraction, division, or addition involved with CPM, you can't do this, right? The only time you can use CPM is when there's just multiplication. The only time you can use CPA is when there's only addition. So most of the time you have combinations of addition, subtraction, multiplication, division, and you got to use PEMDAS. But when that's not the case, certainly you can use these 2 properties. All right. Can we use CPM on this one?
Yes.
Yes. Can we use CPM on this one?
Yes.
No. Oh, check this out. What's let's see. What's 5 times 2? 10. What's 9 times 10?
90.
What's 90 times 10? The answer to this one is 900. But on this one, right? If we don't follow, right? If we just say, well, let's do 9 plus 5 first. 9 plus 5 is 14. 14 times 10 is 140. 140 times 2 is 280. We did not get 900. Right? You have to follow PEMDAS for those right there. Yes?
Can I turn in yesterday's and then Monday's one?
That's fine. All right, box 5. Let's do some. Is everybody with me? We're tracking? Okay. What do you think? What's the best order to multiply here? Genevieve, what do you think?
5 times 6 times 7.
Okay, I agree. 5 times 6 is,
30.
and 3 times 7 is,
21.
so the answer is
200.
210. See how I did that? I would agree. 6 times 5 is 30. And I said not 30 times 7, I just said 3 times 7 and then added 0. So that will happen infrequently, but when it does, it certainly makes your life easy. How about this one? 5 times 4. Okay, 5 times 4 is
20.
2 times 15 is, and add a 0, the answer is 300. Okay? We're all right? Who said no?
I did
Do you agree that 4 times 5 is 20?
the other one.
Which way?
5 times 6.
So the only reason I wouldn't, granted, you're going to get the same answer, but the only reason I wouldn't do 5 times 15, because then you still have a 5. Somebody might have said, well, I can do 4 times 15 easy.
60.
That's 60. 6 times 5, well, that's still 30, but so 300. That's the order you could have done as well, too. It's not that you can't do 5 times 15. You can. Let's see, 5 15s would be what, 75? And 4 times 75, okay, I'm doing scratch work. It's 300. Right. The nice thing about this entire section is, guess what? If you forget CPA or CPM, what can you always do? You can, and what does that mean? What does that mean? PEMDAS, right? Which is what she was saying, order of operations. So if you forget that you can use CPA, CPM, you can always use order of operations to get to the same answer, as long as you do the math correctly, right? All right, looks like we got 2 left. Next property. Use of parentheses. All right, what's the answer here? Let's see, we got to do PEMDAS. 2 plus 3 is
It's
5 plus 4 is 9. Let's move the parentheses and see what happens. Notice parentheses are not around 2 plus 3 anymore. What's 3 plus 4?
7.
Plus 2?
9.
We got the same answer. So this one, notice we did not commute anything. It goes 2, 3, 4. Still goes 2, 3, 4. We didn't commute anything. We didn't move the order around. What we moved were the parentheses. The order stayed the same, 2, 3, 4, 2, 3, 4. What changed was what I put around parentheses. We have a name for this one. This one is called, when I put parentheses around something, I associate two things together. So this is going to be called the of addition. Okay. So this is called the associative property of addition. The associative property of addition says the following. If you only have, you may move the parentheses around anything you want, right? Ooh, that's ugly looking, right? But that's all it's saying. Hey, I only have addition. If I only have addition, I can associate anything I want. Here I'm associating B plus C. Here I'm associating A plus B. All I'm doing is moving the parentheses. This is called the associative property of addition. And just like the commutative property, it only applies to addition and multiplication. We'll talk about that next. Where is your writing? Box 6. Write this down. Associative property of addition. A plus the quantity, B plus C. We read parentheses as the quantity. A plus the quantity, B plus C is equal to the quantity of A plus B plus C. Some people say A plus open parentheses, B plus C close parentheses equals open parentheses, A plus B close parentheses plus C. A little complicated. So instead of saying open and close parentheses, we say the quantity. The A plus the quantity B plus C is equal to the quantity of A plus B, pause, plus C. All right, so notice it still goes ABC, ABC. If the order changes, guess what property it is? Always. If it says A plus ABC on this side and it goes BAC on this side, guess what property that is? I move the things around, what am I doing? The commutative property. You guys are dead. If the order changes, it's commutative property. If the order stays the same, it's the associative property. Because what I'm moving in associative is the parentheses. Still goes ABC, ABC. Look at box 1, 2, 3, 4, 5. Right? The order changed. Instead of going ABC, it went BAC. All right. What's missing? There is no subtraction property. Okay, what's 2 plus 3? 5 minus 5 is, watch what happens when I move the parentheses. 5 minus 2? 3 plus 3 is not 0. That made a big difference, right? We did not get the same answer. There is no associative property of subtraction. All right, the consequences are, once again, if all you have is addition, you can put parentheses around whatever it is you want to add. Okay? So here's an example of APA, associative property of addition. This is telling me what do I got to do first? What is it telling me I must do first?
Oh, add 25 and 13.
I don't want to add 25, 13. I want to add
5 and 25.
So I'm going to use APA to move my parentheses around to add 5 and 25. Did I change the order of the numbers? Did I change the order of the numbers?
No.
It still goes 5, 25, 113. That would be commute if I change it. It still goes 5, 25, 113. What I did do is move the parentheses. That's the associative property of addition. Who's lost? Okay. Oh, by the way, what's the answer?
143.
What?
143.
I couldn't get you to bite. All right. Yes, 143. I was hoping I could change his mind. We good?
Yeah.
All right. Just remember, it's the same, so I keep showing you. If there's any subtraction, multiplication, or division involved, there is no APA. All right. Hey, can we use APA on this one?
Yes.
Can we use APA on this one?
No.
You got it. All right, box 7, let's go. You want to add 7 and 39, or would you rather add 3 and 7? Me too. So what's the answer? See how quickly that was done? Hey, do you want to add 9 and 42, or would you rather add
1 and 9
and 42 and 8? So you can do a double associative property on the second. Let me catch you up here. I could use a double associative property. This one is just associating 9 and 42. Associative property says if all you have is addition, associate whatever you want, like 1 and 9 and 42 and 8. Therefore, the answer is
60.
See how much easier that was? Will that happen in real life? Well, maybe once in the blue moon. It will happen every problem tonight for homework. Literally. Every problem tonight, it will happen. Yeah. And we can combine, I haven't said this yet, if you wanted to commute, you could. Because notice all we have is addition. So if you wanted to move things around and commute, you certainly could. Notice it says 1, 9, 42, 8. It still says 1, 9, 42, and 8. So I didn't commute anything here, but I could have. If I wanted to add 1 and 8, I could do that. All right, looks like we got one left. It is, you can read it.
I can use a social.
Well, it must mean bang your head here because you're tired of properties, right?
Yay, can
All
I
right.
actually?
No. All right. All right, last property for
I
today.
said yes, so I can.
Said yes.
All right. Here we go. A PEMDAS, what's 2 times 3? Times 4.
24.
So I'm still going to write 2, 3, 4, but now I'm going to associate the 3 and the 4. 3 times 4 times 2. We still get to the same answer. Okay? So if you only have multiplication, can you change the associative for what's being associated? You can. We call this the associative property of multiplication. Write this down, please. Associative property of multiplication, APM. Associative property of multiplication. Associative property of multiplication, right. Box 8. I don't care. You're supposed, the rule in class is if you want to work ahead, you have to maintain the, it doesn't matter. You need to stay ahead. We're all taking notes. We are taking notes in class. Okay, associative property of multiplication says the following. You can associate anything you want. So A times the quantity B times C is equal to the quantity B times C, A times B, I said that backwards, times C. A times quantity B times C is equal to the quantity A times B, pause, times C. Good? So notice the order is not changing. I'm not commuting anything. ABC and ABC. What is changing is what I put the parentheses around. The order is the same. Sorry. The parentheses have moved. All right. What can't we do? What's 10 divided by 2?
5.
What's 50 divided by 5?
10.
We get 10. What's 50 divided by 10? Divided by 2? Not 10, right? What would it be? 2.5, right. 5 halves. Okay, so no associative property of division. The consequences, same as previous. If all you have is multiplication, you may put parentheses around whatever floats your boat. What would you rather multiply here? The 6 and the 2, then you got to multiply by 15. How about the 2 and the 15 would be easier, right? 2 times 15 is
30.
times 6. 6 times 3?
180.
2 times 15 was, so it's got 3 in it, right?
I just have 6.
3 times 6 is 18, and then 0, 1, 8. Okay? much easier to do that math. Okay? The goal of this isn't to do the math in your head, right? Obviously, but sometimes that is true. You can. Remember, if all there is multiplication, you can do this. Check. But if there's any addition, subtraction, or division, there is no APM. This one you would have to do PEMDAS, GEMDAS. Okay? All right. Box 9. Which one would you rather multiply? Okay? Some people might say 5 times 12 as well because it still gives you a number that ends in 0. But let's go with 5 times 8. 5 times 8 is? So 4 times 12 is? 48, and that is 0, 480. Why am I not doing times 4? Because some people, as soon as I say, what's 30 times 2, they lose their brain. So I say, what's 3 times 2? And they say 6. That is 0. Okay. Are we done? I do have to show you one other thing. There's a big but here, right? And the big but is this. Homework has decimals. All right. But when you actually look at the decimals, remember, this is the only class where they will give you friendly numbers. Apparently, somewhere in here are friendly numbers that we could commute and associate. Go ahead, Jackson. Tell me which numbers are the friendly ones.
So I would do 4.8 plus 0.2.
Okay, so he's going to commute this one and associate them.
And then I would do, so I put parentheses for
You would commute first and then put parentheses around
yeah,
them.
I would rewrite it like that, and I would do parentheses 1.1 plus 3.9.
Then he would commute the 1, 1 and the 3.9
and
then associate them, and then
I
7 has no friends.
Yeah, exactly.
Okay, so what he's saying is using the commutative property of addition, he's going to move the numbers around. 48 and the 0.2, 1.1 and 3.9, and then once that's done, he's going to put parentheses around the ones that he wants to add first. So that's what he said. I was like a mind reader. I knew what he was going to say. Because everyone would say that, right? So go ahead, 4.8.2. Jackson?
5. Wait. 5.
Is what?
17.
Okay.
What do you mean?
All right. Now, how often is that going to happen? Very rarely.
Hardly ever.
But it will happen in every single problem tonight for homework. Okay?
Yeah, good
So
job.
there's absolutely, I don't know, just friendly numbers tonight for homework, but that will not be the case. Now, sometimes you may look at it and you may not recognize the friendly numbers. If you do not recognize the friendly numbers, you can always do what? You can always do PEMDAS. Okay? Follow order of operations and you will be good to go. Any questions on anything I did? How many problems do you have?
5.
Not many.
No.
All right. If you haven't already started on your homework, get started on your homework. All right. So you have 2 left.
All 3 homework assignments.
Oh, okay, cool. All right. Stay in your seats. Seats. E-learners, you have any questions? Send me. Let's see. Who's in class today? Winter. Good to see you, Winter.
Hey, it's Winter.
Winter, do you want to unmute and say anything? All right. Apparently not. All right. We will see you tomorrow, Winter.
Winter.